Hello friends, welcome to my channel Hima Education Medici. In today's video, we are going to discuss about brief history of rockets. So it all started with a Hero engine, which used steam, steam in order to run it, and then it went with Chinese fireworks, and then moved on to Chinese soldiers who used to launch these fireworks, and then it went to water surface attacking, so like surface running torpedoes which are used on water surfaces, and then it went with legendary Chinese official Van Hu Brazos himself for liftoff. So he arranged a sort of chair, and to which he attached some sorts of fireworks, and he lit himself up, and he traveled some sort of distance, and then it went with Dr. GODRADS 1926 rocket experiment. Then it went with German V2, that is A4 missile. Then here if we see, today's rockets are remarkable collections of human ingenuity that have their roots in the science and technology of the past. They are naturally outgrowths of literally thousands of years of experimentation and research on rockets and rocket propulsion. One of the first devices to successfully employ the principle essential to rocket flight was wooden bird. The writings of Aulus Gellius, a Roman, tells a story of Greek named Archats who lived in city of Tarentum, now a part of southern Italy. Somewhere around the year 400 BC, Achat mystified and amused the citizens of Tarentum by flying a pigeon made of wood. Escaping steam propelled the bird suspended on wires. The pigeon used the action reaction principle, which is not stated as scientific law until 17th century. About 300 years after the pigeon, another Greek hero Alexandria invented a similar rocket-like device called an aeroplane. It, it too used steam as propulsive gas. So here you can see it as a hero engine, as because of Hero of Alexandria invented it. And then Hero mounted a spear on top of a water catler. A fire below the catler turned the water into steam, and the gas traveled through the pipes of a spear. Two L-shaped tubes on opposite sides of the spear allowed the gas to escape, and in doing so gave a thrust to the spear that causes it to rotate. Just when the first true rockets appeared in unclear, stories of early rockets like devices appear sporadically through the historical records of various cultures. Perhaps the first true rockets are accidents. In the 1st century AD, the Chinese reportedly had a simple form of gunpowder. So before going to this gunpowder, we'll just see this one. So here he used a fire below it, and he used two L-shaped devices which are used to which are used to guide the steam into this spear, and there are two more L shapes that are placed in opposite direction, and with the help of this thing it used to rotate in and opposite direction. Okay, then just when the five true rockets appeared, it is unclear story as we have seen. So accidentally Chinese invented these rockets. The Chinese reportedly had a simple form of gunpowder made from saltpeter, sulfur, and charcoal dust. To create explosion during religious festivals, they filled bamboo tubes with a mixture and tossed them into fires. Perhaps some of these tubes failed to explode and instead skittered out of the fire, propelled by the gases and sparks produced by the burning gunpowder. So here you can see a diagram in which Chinese attached these fireworks to these arrows in order to launch them. Okay, the Chinese began experimenting the gunpowder filled tubes. At some point they attached bamboo tubes to arrows and launched them with bows. Soon they discovered that these gunpowder tubes could launch themselves just by the powder produced from the escaping gas. The true rocket was born. So here they used to attach it and they used to launch and ignite it. But as time progressed, they started to just ignite it in order to launch them. The date reporting the first use of rockets was in 1232, that is 1232. At this time, the Chinese and Mongols were at war with each other. During the Battle of Kai Kang, the Chinese repelled the Mongol invaders by a barrage of arrows of flying fire. These fire arrows was a simple form of solid propellant rockets. A tube capped at one end contained gunpowder. The other end was left open and the tube was attached to a long stake. When the powder was ignited, the rapid burning of the powder produced fire, smoke, and gas that escaped out the open end and produced a thrust. The stick attached as a simple guidance system that kept the rocket head in one general direction. It is flew through the air. It is not clear how effective these arrows of flying fire were as weapons of destruction, but their psychological effect on Mongols must have been formidable. Following the Battle of Kaikeng, the Mongols produced rockets of their own and may have been responsible for spread of rockets to Europe. Although the 13th to 15th centuries there were reports of many rocket experiments in England, a monk named Roger Bacon worked on improved forms of gunpowder that greatly increased the range of rockets. In France, Jean Froissart found that more accurate flight could be achieved by launching rockets through tubes. Forrest's idea was the forerunner of the modern bazooka. Johannes de Fontana of Italy designed a surface running rocket powered torpedo for setting enemy ships on fire. So here this one is surface running torpedo. It can be used to launch on surface of water. By 16th century, rockets fell into a time of disuse as weapon of war, though they were still used for fireworks display, and German fireworks maker John Schimblap invented the step rocket, that is called a multi-stage rocket. Okay, multi-staged vehicle for lifting fireworks to higher altitudes. A large sky rocket's first stage carried a small sky rocket's second stage. At first stage they used to use large sky rockets, and whereas then it is followed by a small sky rockets in order to increase the range. When the large rocket burned out, the small one continued to higher altitude before showering the sky with glowing cinders. Skindalp's idea is basic to all the rockets today that go into outer space. Nearly all uses of rockets up to this time were for warfare or fireworks, but there is a interesting old Chinese legend that reported the use of rockets as a means of transportation. With the help of many assistants, a lesser known Chinese official named Wang Hu assembled a rocket powder flying chair. Attached to the chair were two large kites, and fixed to the kites were 47 fire arrow rockets. So he attached two Chinese kites and around 47 fire arrow rockets to a chair, and then he ignited it. On the day of the flight, Van Hu sat himself on chair and gave the command to light the rockets. 47 rocket assistants, each armed with a torch, rushed forward to light the fuse. In a moment, there was tremendous roar accompanied by billowing clouds of smoke. When the smoke cleared, Van Hu and his flying chair were gone. No one knows for sure what happened to Van Hu, but it is probable that if the event really did take place, Van Hu and his chair were blown to pieces. Fire arrows were as apt to explode as to fly. Rocketry became a science after that. During the latter part of 17th century, the scientific foundation of modern rocketry were laid by great English scientist Sir Isaac Newton. In between the period of 1642 to 1727, Newton organized his understanding of physical motion into the three scientific laws. The laws explain how a rocket works and why they are able to work in the vacuum of outer space. Newton's laws soon began to have a practical impact on the design of rocketry, and about 1720, a Dutch professor, William Gravensen, built model car propelled by jets of steam. And then the rocket experiments in Germany and Russia have begun, working with the rockets with a mass of more than 45 kilograms. Some of these rockets were so powerful that their escaping exhaust flames bored deep holes in the ground even before liftoff. During the end of 18th century and early into 19th, rockets experienced a brief revival as a weapon of war. The success of Indian rocket barrages against the British in 1792 and again 1799 caught the interest of artillery expert Colonel William Congreve. Congreve set out to design rockets for use by British military. The conversion the Congreve rockets were highly successful in battles used by British ships to pound Fort McHenry in War of 1812. They inspired Francis Scott Key to write the rocket's red glare, words in his poem that later became the Star Spangled Banner. Even with Congreve's work, the accuracy of rockets still had not improved much from the early days. The devastating nature of war rockets was not their accuracy or power, but their numbers. Okay, then during a physical siege, thousands of them might be fired at the enemy, and all over the world rocket researchers experimented with ways to improve accuracy. An Englishman, William Hale, developed a technique called spin stabilization. In this method, the escaping exhaust gases struck small veins at the bottom of the rocket, causing it to spin much as bullet does in flight. Variations of the principle are still used today. Rockets continue to be used with success in battles all over the Europe continent. However, in war with Prussia, the Austrian rocket brigades met their match against newly designed artillery pieces. Breech loading cannon with a rifle barrel and exploding warheads were far more effective weapons of war than the best rockets. Once again, rockets were relegated to peacetime use. Modern rocketry begins in 19th in 1898, a Russian school teacher, Konstantin Tsiolkovsky, in 1857 to 1935, proposed the idea of space exploration by rocket. In a report he published in 1903, Tsiolkovsky suggested that the use of liquid propellant for rockets in order to achieve greater range. Tsiolkovsky stated that the speed and range of rocket were limited only by the exhaust velocity of escaping gases. For his idea, careful research, and great vision, Tsiolkovsky has been called the father of modern astronautics. Okay, so here Tsiolkovsky is the first scientist, first scholar, first teacher, we can say it as, who thought of using liquid propellants and developed a small scaled model. So here you can see a model over here. Okay, and then in early in 20th century, an American, Robert H. Goddard. So here this one is invented by Dr. Goddard. So this rocket. Okay, so Goddard, Robert H. Goddard, conducted practical experiments in rocketry. He had become interested in a way of achieving higher altitudes than were possible for lighter than air balloons. He published a pamphlet in 1919 entitled A Method of Researching Extreme Altitudes. It was a mathematical analysis of what is today called the meteorological surrounding rocket. Meteorological sounding rockets. Okay, so in Goddard's earliest experiments were with the solid propellant rockets, and in 1915 he began to try various types of solid fuels and to measure the exhaust velocity of burning gases. While working on solid propellant rockets, Goddard became convinced that a rocket could be propelled better by liquid fuels. No one had ever built a successful liquid propellant rocket before. It was much more difficult task than building solid propellant rocket. Fuel and oxidizer tanks, turbines and combustion chambers would be needed for this. In spite of the difficulties, Goddard achieved the first successful flight of liquid propellant. Okay, so here the father of modern astronautics is Tsiolkovsky, who proposed liquid rocket propulsion system. Then whereas Goddard, Robert H. Goddard, is the person who successfully experimented this liquid rocket propulsion systems. In spite of the difficulties, Goddard achieved the first successful flight with a liquid propellant rocket on March 16, 1926, fueled by liquid oxygen and gasoline. The rocket flew for only 2.5 seconds, climbed 12.5 meters, and landed 56 meters away in Cabbage Patch. By today's standard, the flight was unimpressive, but like the first powered airplane flight by the Wright brothers in 1903, Goddard's gasoline rocket was the forerunner of a whole new era in rocket flight. Goddard's experiments in a liquid propellant rocket continued for many years. His rockets became bigger and flew higher. He developed gyroscope system for flight control and payload compartments for scientific instruments. Then parachute recovery systems were employed to return rockets and instruments safely. Goddard, for his achievement, has been called as father of modern rocketry. So here we are having two main scientists. One is Tsiolkovsky, who is a father of modern astronautics, and one is Goddard, who is father of modern rocketry. A third great space pioneer, Hermann Oberth, in 1894 to 1989, He was born on June 25th, 1894, in Hermannstadt, and died on December 28th, 1989. Uh, in Nuremberg, Germany, published a book in 1923 about rocket travel into the outer space. His writings were important. Because of them, many small rocket societies sprang up around the world. In Germany, the formation of one such society, the Verein for Ram Ramskyfad Society for Space Travel, led to the development of the V2 rocket, which was used against London during World War II. In 1937, German engineers and scientists, including Ober, assembled in Penemünde on the shore of Baltic Sea. There, the most advanced rocket of its time would be built and flown under the direction of Werner von Braun. Then the V2 rocket in Germany, called it as A4 missile, okay, was a small rocket was small by comparison to today's rocket. It achieved its greatest thrust by burning a mixture of liquid oxygen and alcohol at the rate of about 1 ton every 7 seconds. Once launched, the V2 was a formidable weapon that could devastate whole city blocks. Fortunately for London, the Allied forces, the V2 came too late in the war to change its outcome. Nevertheless, by war's end, German rocket scientists and engineers had already laid plans for advanced missile capable of spinning the Atlantic Ocean and landing in United States. These missiles would have had winged upper stage but very small payload capabilities. So here you can see it that very small payload capabilities are there for this German V2A4 missile. With the fall of Germany, many unused V2 rockets and components were captured by allies. Many German rocket scientists came to the United States. Others went to the Soviet Union. The German scientists, including Werner von Braun, were amazed at the progress Goddard had made. Both the United States and Soviet Union realized that the potential of rocketry as a military weapon and began a variety of experimental programs. At first, the United States began a program with high altitude atmospheric sounding rockets. One of Goddard's early ideas, then later a variety of medium and long range intercontinental ballistic missiles were developed. These became the starting point of the US space program. Missiles such as Redstone, Atlas, and Titan would eventually launch astronauts into space. Then on October 4th, 1957, the world was stunned by the news of Earth orbiting artificial satellite launched by Soviet Union called Sputnik 1. The satellite was the first successful entry in a race of space between the two superpower nations. Less than a month later, the Soviet followed with a launch of satellite carrying a dog named Laika on board. Laika survived in space for 7 days before being put to sleep before the oxygen supply ran out. A few months after the first Sputnik, the United States followed the Soviet Union with a satellite of its own. Explorer I was launched by US Army on January 31st, 1958. In October of the year, The United States formally organized its space program by creating the National Aeronautics and Space Administration, that is NASA. Okay, NASA became a civilian agency with the goal of peaceful exploration of space for the benefits of all humankind. Soon, many people and machines were being launched into space. Astronauts orbited Earth and landed on the moon. A robot spacecraft traveled to the planets. Space was sorry Satellites enabled scientists to investigate our world, forecast the weather, and to communicate instantaneously around the globe. As the demand for more and large payloads increased, a wide array of powerful and versatile rockets had to be built. Since the earliest days of discovery, the experimentation, rockets have evolved from a simple gunpowder devices into giant vehicles capable of traveling into outer space. Rockets have opened the universe to direct exploration by humankind. With this, I will be winding up this session. If you like the video, please do like, share, and subscribe.